It isn't particularly rare, and it's certainly not glamorous, but the metal we're looking at today is arguably the single most important material that's going to power our future. It's so fundamental to everything we do that we often just overlook it. Yet it's this hidden in plain sight element that underpins nearly every piece of technology we rely on. So today we're going to unpack why the world is suddenly waking up to the critical importance of copper.
To really understand where we're going, it helps to start where modern electricity began. Copper's story is completely intertwined with the story of electrification itself. When Thomas Edison first lit up that square mile of New York City, it was tens of thousands of feet of copper wire that actually carried the current. It was the essential medium back then, and as we're about to see, it still is today.
For more than a century and a half now, this one element has been the connective tissue of our civilization. It's inside the walls of our homes, it's in the engines of our cars, and it makes up the vast networks that power our entire economies. It is, quite literally, the metal that has wired our modern world into being.
And it's because of this foundational role that copper is now being seen through a completely new strategic lens. It's not just another industrial commodity anymore. The United States, for example, has officially designated it a critical mineral, which is a formal way of saying that our future progress, our security, and our economy all depend on having a stable supply of it.
A good way to think about it is to picture copper as the physical artery of our technological society. It's the essential link that connects the machines that do the work, the digital intelligence that guides them, the infrastructure that supports them, and even the security systems that protect them. It's the one material that really does tie it all together.
So while copper has always been important, we're now standing at the very beginning of a completely unprecedented new wave of demand. Several massive global trends are all converging at the exact same time, and they all share one thing in common. They require truly enormous amounts of copper. This new surge is really being driven by four main forces, all acting at once. The foundation, of course, is the core economic growth that's always driven copper demand. But now you have to layer on top of that the immense needs of the green energy transition. And a third, really powerful new driver has just emerged: the explosive growth of AI and data centers. And then finally, a global push towards defense modernization adds yet another layer of demand on top of it all. Let's just take the energy transition for a really tangible example. An electric vehicle isn't just a car with a battery. It's an incredibly copper-intensive machine. In fact, it requires nearly 3 times more copper than a traditional car with an internal combustion engine. Now imagine as millions and millions of these vehicles hit the road, the cumulative effect on copper demand is just enormous. This really reveals the hidden material cost of our digital world. You see, the AI revolution literally runs on electricity, and data centers are incredibly power-hungry. Projections are now showing that by 2030, they could consume up to 14% of all electricity in the United States alone. While powering all that growth requires a massive build-out of copper, both inside the data centers themselves and across the entire grid that has to support them. So when we look ahead to 2040, we can really see the combined pressure of all these forces. While traditional economic growth is still a major driver, it's actually dwarfed by 2 massive new sources of demand. The energy transition is projected to be the single largest driver of new growth, and it's followed closely by the relentless needs of AI and data centers. Together, they are creating a cumulative demand surge unlike anything we have ever seen before. So, we've just laid out this very clear picture of soaring demand coming from multiple directions. But that's only one half of the economic equation, and this brings us to the central conflict of this entire story. This growing and potentially severe mismatch between what the world is going to need and what the world can realistically produce. This is the fundamental question that policymakers, investors, and entire industries are now grappling with. Given the sheer scale of this new demand, can our global supply systems possibly respond in time? The analysis points to a pretty stark conclusion. Without a significant expansion of our ability to supply it, the world is facing a projected annual shortfall of 10 million metric tons of copper by the year 2040. Now, this isn't a minor imbalance, it's a structural deficit, and it has profound implications for global growth and technological development. This gap isn't expected to just appear overnight. Today, the market is more or less in balance, but as the coming decades unfold, projections show demand pulling away dramatically from our current supply trajectory. By 2040, that gap widens into the 10 million ton shortfall we were just talking about.
So this leads to the obvious next question. If we know this is coming, why can't we just mine more copper?
Well, the reality is that increasing supply is incredibly difficult, and it's fraught with challenges, both below the ground in the mines themselves and above the ground in the worlds of finance, regulation, and politics.
A really crucial point to understand here is that bringing a new copper mine online is an incredibly slow and capital-intensive process. The average timeline from the initial discovery of a deposit to the first day of actual copper production is about 17 years. And a huge portion of that time is spent just navigating complex and often incredibly lengthy permitting and review processes. It's also important that we make a distinction between what exists in the ground and what's actually accessible to us. The term resources refers to all the copper we think is in the Earth's crust. But reserves, well, that's the much smaller fraction of that total that we have confirmed, and that can be extracted economically with current technology and under current regulations. Just because copper is in the ground doesn't mean we can get to it.
The challenges really exist both above ground and below ground. Geologically, the quality of copper ore, what miners call ore grade, is declining. This means they have to dig up and process much more rock to get the same amount of copper, which of course drives up costs. And at the same time, above ground, they face rising expenses for things like energy and labor, alongside unpredictable regulatory environments and permitting timelines that can stall projects for years on end.
Okay, so the situation is challenging, but it's not without solutions. Addressing this looming shortfall is going to require a multifaceted approach. It's not about finding one single silver bullet, but rather advancing on multiple fronts at the same time to build a more resilient and responsive supply chain.
Recycling is an absolutely critical piece of this puzzle. Copper is infinitely recyclable without losing its properties, which is a huge advantage. However, even with very aggressive assumptions about improving our ability to collect and reprocess used copper, this secondary supply can only meet about a third of our total needs by 2040. It is essential, yes, but it cannot close the gap on its own.
Therefore, the path forward really rests on three key pillars. First, we have to find ways to safely and responsibly accelerate the development of new mines. Second, we need to invest heavily in the infrastructure to maximize recycling. And third, we must foster technological innovation across the entire value chain, from new extraction techniques to more efficient ways of using the metal in the final products. And this really underscores the stakes. We are at a critical juncture. The decisions that are made today around investment, around policy, and around technology are going to determine whether copper is the great enabler of the future we all envision, or if it becomes the primary constraint that holds it back.
And so, we're left with this fundamental question. The demand for copper is crystal clear, driven by the defining technologies of our time, from clean energy to artificial intelligence. The supply challenges are equally clear. How we navigate the path between them will ultimately shape the pace and the direction of human progress for decades to come.